Hello and welcome to this third installment of our ArcSight SmartConnectors series on the Amazon Web Services Smart Connectors. This session is based on the new Security Hub connector, which is a brand new addition to our Smart Connector framework as of version 8 of the Smart Connector framework. And this connector deserves its own sort of session to actually run through its capabilities and where our strategy is really heading for event collection from a security perspective within ArcSight. You may be aware that there are two other videos available for your viewing around Amazon Cloud Trail and also Amazon Cloud Watch. And if you've watched those videos, you'll know that they actually work in quite different ways. They also are centered around different types of events. And what I wanted to do in today's session was actually explain how this new Security Hub connector works from a deployment perspective, the services that it uses with Amazon and so forth, but then most importantly show you the different types of events that you're actually going to receive and how they differ greatly from Cloud Watch and Cloud Trail. So if you're unfamiliar with what Cloud Security Hub is all about, let's take a quick look at what Amazon says about it. Security Hub gives you a comprehensive view of your high priority security alerts across all of your accounts. And so we have a wide range of security tools at our disposal, such as firewalls, endpoint protection, and so forth, through to vulnerability and compliance scanners. With Security Hub, you have a single place that aggregates and organizes all your different security alerts, such as Amazon Guard Duty, Inspector, Macy, IAM, and so forth. So basically what Security Hub is this central location for security findings to actually be placed and then consume. And this is what we plan on doing with our new Smart Connector. Let's consume those security relevant events and bring them into an ArcSight destination. There's many different types of services and products and so forth that can actually feed into and even pull out events from Security Hub. The particular service that we are interested in today in our initial release of this connector is called Amazon Guard Duty. And Amazon Guard Duty is of course a managed security service within Amazon, which effectively is a threat detection service that continually monitors for malicious activity and unauthorized behavior to protect your AWS accounts and workloads. So it's effectively its own miniature SIEM/SOC service, and it is sending the security findings to Security Hub. And it does this via a couple of other Amazon services, which we'll have a look at right now. So think of it straight away as being that service that is taking a lot of the legwork out of correlation and analytics and so forth and doing it all for us, and then it's just sending us that smaller number of events that are events that need to be acted upon. So we're not trawling through potentially thousands and thousands of events looking for something that may be malicious. It's taking a lot of the workload for us in our cloud deployments away from what we need to be doing. So the Smart Connector configuration document is available, and I want to take you firstly to the actual architecture of the connector to help explain how Security Hub, Guard Duty, and our Smart Connector actually all fit together, because this is an important point. Because if you've watched the other two videos on Cloud Trail and Cloud Watch, you'll know that they work in very different ways, and the Security Hub connector is different yet again. It's almost like a mixture of the methods and services that are used in the other two connectors to bring us the Security Hub events. So starting from the top here of the configuration guide, in the cloud we've got these different services as we saw before: Guard Duty, Inspector, Macy, third-party integrations and so forth. And all of these services are effectively what we like to call Security Hub enabled. So they will create findings, they'll do the analysis, they'll create findings, and they'll send them through to this Security Hub service. And Security Hub receives events in AWS Security Findings format, or ASFF. And it does this and then sends them across to what we call Event Bridge, which is another Amazon service which is sort of taking care of it for us. We don't need to worry about that too much. But as you may be aware, our CloudTrail connector, we introduced this concept of using the SQS service or simple queuing service. And this is really how Security Hub is working as well. So when a new event actually arrives in the event bridge, it actually sends a message to the queue. And the queue is being polled by our lambda function, and if the lambda function is effectively running our smart connector. So what happens is basically our Java code here polls the queue, it sees that there's a new message available, it goes and gets that event from the event bridge, and then processes it from the ASF format into Ceph format. And then after that, it sends it off to the destination that we pre-configure, which is of course a Ceph syslog ng connector running on a given port over TLS. And this is where we have the concept of the syslog ng daemon running in a private subnet within your VPC, which can then obviously forward off to ArcSight and non-ArcSight destinations for further processing. So just to reiterate, the Security Hub aware or enabled services such as GuardDuty send their findings. So GuardDuty is doing analysis and so forth of CloudTrail and CloudWatch logs in the background, something that we would have normally done ourselves within ESM, for example. But GuardDuty is doing a lot of that work for us now and only sending us the findings that it has. Sends them onto Security Hub. It drops them into Event Bridge. It sends a message to the SQS service saying, hey, I have a new message, I have an event you need to come and collect. Our Java code, effectively our smart connector running in Lambda, will pick up that message, pull the message, convert it from ASFF format into Ceph, and then send it onto our syslog ng daemon, and then we're free to actually send on to any destination that we want to after that. So this brings us to a really good point in that Security Hub is and our GuardDuty are going to give us very, very much a subset of events that actually are occurring within our VPC. If you're familiar and have seen CloudTrail and CloudWatch working at a VPC or a level, you'll know that it can generate a lot of events. So let's take a quick look at those events to give you an idea. So here's my ESM. I've got 3 different active channels running here now. This first one here on the left is for CloudWatch, and as I've described before in previous videos, CloudWatch is really centered around those operational and API type calls. So you'll see basically calls to your VPC infrastructure, whether it be via the console or via an API call, and that's why you see a lot of different calls such as describe tags, assume role, all these sorts of things that services and humans are calling upon to do their roles on a day-to-day basis. So it's pretty operational. There's not a whole lot of truly security-centric events in here. Secondly, if we then pop over here to our CloudWatch active channel, you'll notice that we're really looking with the CloudWatch logs via VPC flows, and we start to see a lot of different things or items around accepts and rejects at a security group level. So incoming traffic trying to hit my infrastructure internally, internal traffic accepts and denies and so forth. So what I set up from a network access perspective, security group perspective and so forth, those accepts and rejects will be reflected in these VPC CloudWatch logs. And again, there are a lot of logs. There is a lot to consider here. The EPS rates tend to be quite high, so this is something else to consider. But what's really wonderful about Security Hub is that if I now pop over to my Security Hub SmartConnector active channel, you'll see that out of all of those incoming events that I would typically be analyzing myself, I can have GuardDuty just tell me about what's really most important. I can use my CloudWatch logs and do further analysis for my own reasons, my own use cases and so forth, but Security Hub is doing a lot of great security work for me. So you'll notice here, even over the last 3 days, I've only had a few alerts. Now I've got a very, very small infrastructure here with virtually no virtual machines, so I'm not going to see a whole lot here. But the point that I want to make here is that as I said before, there's very much a subset of events, but they're solely centered around security and security alone. So if we take a look at this DNS request target, for example, this is effectively a DGA call. GuardDuty has seen a DNS request come through, and it has analyzed against its own security capability, and it said, right, this is actually a DGA call, and I'm going to send off a finding to Security Hub. And so I've got one event for possibly thousands of events that need to be analyzed. This is a really great piece of functionality and service that Security Hub offers us. So just to reiterate, CloudTrail, very operational. CloudWatch, great for accepts and denies and network level type ACL information in terms of logs and events. And then Security Hub itself, we're taking advantage of that managed service GuardDuty to bring us just what it finds in terms of security findings. But it's important to point out that this initial release of the connector is centered around GuardDuty. So as you start to read the documentation for this connector, it is very clear that it is for GuardDuty. Even though Security Hub has the ability to send us lots of different findings for lots of different reasons and causes, we're centered around, for our initial release, this GuardDuty piece. So make note of that. It is not going to give us events from third-party integrations at this point, but they are certainly on the horizon. The next thing I want to show you is the networking and AWS side of the configuration, which needs some consideration, and there's a few steps involved to actually getting it set up and working. So it's not just a case of simply installing a syslog ng connector and hoping for events to come through. There are a few caveats and stipulations around the network and how it actually hangs together. So I want to run through that right now. Firstly, you're going to have a VPC. That would make sense in Amazon. My VPC has a CIDR block here, /16 of 172.31. I do give an even more detailed iteration of the VPC and networking setup in the CloudWatch video. So if you're looking for a step-by-step demonstration of how to perform that, please watch the CloudWatch video. I actually install all of the VPC from scratch, but in this video I'll just step you through what I've actually done. Make it work. So first of all, we've got this VPC. We're going to have, and a requirement of Lambda is to actually work within a private subnet. If you're not familiar with private and public subnets in Amazon, effectively a private subnet is one that does not by default have internet access. And secondly to that, a public subnet is one that can have internet access via what we call an internet gateway, and it can have public addresses assigned to internal hosts. So it's effectively saying a private subnet by default, unless you add a NAT gateway to it, it will not have any access outside to the outside internet. And this is sort of a stipulation on Lambda. It must run in the context of a private subnet. And so this is why I've created these private subnets A, B, and C across my 3 availability zones. So effectively I'm giving Lambda, or in essence our SmartConnector, the ability to run and execute within that private state. These private subnets are attached to this second route table that I have. In Amazon, you'll have typically a default route table which takes care of basically everything local to the VPC itself, but then anything outside of that, wanting to go to the internet, will go via typically a default enabled internet gateway. And so this is really what a public subnet would be utilizing to gain access to the internet. But what we do is we create a new route table, and we associate our private subnets with this route table. So we're basically saying anything that these private subnets want to do, they need to have this route table applied to them. And of course, Lambda can often require internet access for gaining access to various services, and that creates a real problem. So we need to actually create what's called a NAT gateway to give that functionality, that Lambda function, internet access one way, so to get out to the internet. And so to do that, we actually create one of these NAT gateways. It's important to keep in mind that a NAT gateway for your customer instantiating one of these is a managed service by Amazon and does carry a per month cost. So be aware of that. You might also want to look at implementing your own NAT device to bring that cost down. So that's just something to keep in mind. So under the route tables here, we'll go back to our private route table, and you'll notice that anything from my associated private subnets here stays within this particular route table. If any traffic needs to go outside of my private subnet, I've created a new capsule route table rule to go via the NAT gateway. So it's a bit like your home router or your typical small business where everything's sitting behind a single NAT gateway. Anything wants to get outside of the local subnet, it goes via this NAT device. It's as simple as that. And so they're the few steps that we need to actually make sure are in place before we set up any of these connectors, because when we set up this connector, we actually associate our lambda function with these private subnets, and that allows it to have the access to the various services that it requires. But again, if you'd like a step-by-step demonstration of building this from scratch, watch the CloudWatch video for those steps. So I just wanted to quickly take you through Security Hub as a service within Amazon. I won't go into a whole lot of detail here, but I just wanted to point out that Security Hub can be enabled for a free 30-day trial in your Amazon account. So I certainly encourage you to have a look at that. It might also be a great way to run POCs, etc., with very little cost. But once you have it up and running and enabled, you can switch on these various services such as GuardDuty. And GuardDuty has its own console. I'll bring that up now. And in the background here, it's obviously utilizing VPC logs and so forth, analyzing those for us in the background, and then coming out with these findings. So there's a couple of things here that are of interest to me already. I've got some DGA domain requests, things like that, drive-by source traffic, etc., root credential usage and so forth. So these are great. These are typically things that I would need to do in my own SIEM, for example, but I can let GuardDuty do that work for me. And the nice part about it is, out of all the tens of thousands, potentially millions of events that it's actually processing, there's really only about 5 events that need to end up in my ESM console, and I can act upon those. So this is a really great feature within Amazon. As I said, you can build at a free trial, and you can also do some configuration here. So GuardDuty is just one piece. As I said, there's lots of different services like Macy and third-party integrations and so forth from many other security vendors. But at this stage, as an ArcSight SmartConnector, we support GuardDuty today as of its initial release in 8.0, and we'll push forward with further enhancements and integrations as time goes on. So that's just a quick look at the GuardDuty and the Security Hub console. And keep in mind that, as I said before, GuardDuty is what we support today. So you'll notice that although I have some GuardDuty events, I'm not seeing these Security Hub events here, such as these essentially vulnerability scans and so forth, because these are not coming from GuardDuty, they're coming from other services. So I want to make it very clear that we won't see those in our initial release of this smart connector, because we are focused on GuardDuty itself. So just keep that in mind. Next, let's take a look at the actual connector framework and what we can expect in terms of the files and so forth that we need for a successful installation. So I've unpacked version 8 of the connector framework into a temporary folder here so we can take a look at it. And it looks very much the same as any other connector framework deployment from the 7 series, 7.14 and 5. This is, of course, 8.0, our initial release. And we've got our Windows collectors, connectors, Linux, etc., etc. So nothing surprising here. But one of the really nice additions is, of course, the Security Hub connector. And you'll find that as a small zip file, just like the CloudWatch connector. It's a small zip file down the bottom here. So when we unpack it, I just want to quickly run through the files that are part of this actual connector, just so we're very clear on what we're actually sending up to the S3 buckets and what the function of each of these actual files is. So this is all the files from the Security Hub connector that I've unpacked, that zip file. We've got a maps file, a maps directory, which contains all of our mappings for the ASFF format through to Ceph, and at this stage it's really centered around guard duty. We've got the Security Hub connector jar. So this is effectively our event processor for processing ASFF to Ceph files. So this is effectively that Java code for parsing to Ceph. It's as simple as that, and that's the piece that runs inside of Lambda in a serverless configuration for parsing of events. We've got external.properties, and external.properties, if we take a quick look at my external.properties, it's just like very similar to the CloudWatch connector in that you provide the upstream syslog connector and G information. You also provide things like the actual S3 bucket for where we will find our remote management certificate for our syslog ng connector or load balancer. One interesting change you'll see is that the password is now obfuscated as opposed to plain text as it was in 7.1 of the connector framework, particularly for CloudWatch. And then, of course, our map overrides folder as well. Last but not least, and so in saying that, external.properties will go into our S3 bucket as well. What doesn't go into the S3 bucket is this installer.json file, and this is effectively our CloudFormation template, and this is what we will actually feed in to the CloudFormation setup process, which I'll go through next, and that contains all of the policy creation and so forth around roles and resources and so forth that are generated and created for the purpose of running the event processor.jar file in Lambda. So that's another important file there. But again, we won't actually put that on the S3 bucket. We'll actually upload that to the AWS console. So that's a quick look at the files that are involved with the actual connector itself in AWS. All right, so there's a number of other steps we've got to partake in to actually deploy the connector. Like I said before, each of our connectors has been a slightly different install process because we're utilizing different services and so forth within Amazon, and the Security Hub connector is in the same bucket, so to speak. So as per the documentation, we've got a number of different steps we've got to take, but arguably a little bit more straightforward than the CloudWatch connector. I showed you in the previous section where we set up the VPC and networking side of things, so we're good to go there. And basically the next step is to now upload all of the relevant files for the Smart Connector or the Lambda to actually execute and parse these Security Hub events into Ceph and then send them on to the syslog daemon. So what we firstly do is set up a new S3 bucket. You can see I've got a CloudTrail and a CloudWatch bucket there from our previous videos and previous demonstrations. We'll leave them in. So this security bucket here I've aptly named Security Hub bucket. I click on it and I go into it, and effectively what I do now is upload all of the files from the SmartConnector.zip file that you'll find in amongst the Smart Connectors. So this is not the syslog ng Smart Connector, this is the actual Security Hub connector itself. And what we're going to be uploading is several different pieces of information. Firstly, there's going to be the maps folder that we upload. So this is all the different map files for the different type of guard duty events and so forth that we support. We've got the event processor itself, so Security Hub connected 1.1.jar. So that's obviously very important. This is effectively the Java code that gets sent to Lambda for execution. External.properties, we need to update that with the relative information for Lambda to actually read when it invokes itself. It will pull that information down, that file, it will read the properties and so forth, and from there it works out where it needs to go to next. Installer.json is basically a template for CloudFormation, and that's an important file. We'll get to that very shortly. It's effectively setting our policy for what services and so forth and how our connector will actually run. So very important there. Just like the CloudWatch connector, we need to upload the remote management certificate from our syslog-ng SmartConnector or our load balancer if we're going down that path. So once you've installed your syslog-ng connector, make sure that you give copy remote management.p12 into this bucket as well. Now I've been particularly lazy here. I've just put them all in the root folder. Obviously we would, under best practices, we would create a new subfolder, Security Hub files or something like that, and then place all these files under there. But I have just placed them all in the root folder. Not best practice. So let's take a look now at external.properties, and it's very similar to what we saw in CloudWatch, but just a couple of minor changes and actually a few deletions actually. Firstly, our host and port names, port number, so where we're sending our Ceph events downstream, right? So we obviously need that. You'll notice that 98.242, that was my syslog-ng in the private subnet. So my syslog-ng connector has no real way of getting out at this stage, but Lambda can talk to it because we will associate Lambda with the private subnet. Port 1999, it will be a TLS-based syslog-ng connection. That's what we must stipulate. It is a TLS connection. And then we've got our certificate information here as well. So we're telling the installer we're going to be going to our Security Hub bucket. Now the bucket must be in the same region as the connector itself, so be aware of that. We're telling it where our actual certificate is, and if I was being a little bit neater in how I did things, I would put it in a subfolder, but I haven't done that at this stage. One thing you'll notice in the new version is that we're actually using the obfuscated password for the key store password, which is a nice addition. In the past and in CloudWatch in the 7.1 series, you'll notice that it's actually in clear text. So that's a nice little change to security there. Map override bucket. And also the folder. So this is this maps folder here. So if I've got extra map files and I can switch on or off logging, info, debug, etc. and so forth. So as long as we've got all that information, we save that file. We then upload it here, as you can see. In terms of the remote management port certificate, you'll remember that that is under user agent, and you'll see that P12 file there under current user agent. So we grab a copy of that, we dump that also into the S3 bucket, and that's all that we need to do from an S3 perspective. So we're pretty much ready to go. So next we're actually now going to move on to the actual CloudFormation template installation. So this is where we deploy the actual event processor itself. So let's get started on that one. So to get over to CloudFormation, what we do is we simply click on services on any console within AWS. Easiest thing to do is just type the word formation. There's a number of different answers that will come up. We want to click on CloudFormation. And you'll notice here that I've already got a stack, my CloudWatch stack. So we utilize stacks for the CloudWatch connector, as you remember from the previous video. And we do it in a very similar fashion here, but instead of using an actual installer script like you might remember, we're actually going to use a template this time. So it's even a little bit cleaner and neater and nicer to work with. So let's go ahead and do that. So firstly, we click on Create Stack, and with New Resources Standard, and we're going to use we're going to use a template, and we have the option of uploading a template file or using an Amazon S3 URL. So we'll use a Amazon URL. So let me just quickly go back to the bucket, And what we're going to be doing is grabbing the file locator information for the installer.json file. So we've copied that URL, bring it back to the CloudFormation piece, and we just simply pop it in there. Click on Next. Give it the bucket name where the everything is available. As we know, it's in Security Hub bucket. It's going to be in the same region. We give the stack a name to begin with. We grab the bucket name, which is Security Hub bucket. The region, AP-Southeast-2 in my case. Make sure you get this right because it is all regional. You'll notice in the documentation, certainly in this pre-release stages, you do actually set up a security group for the lambda function, but inbound or outbound rules. But you do have to select something. So you can actually just create an empty security group if you want, with no inbound or outbound rules. But I'll just copy over the one that I'm using from CloudWatch because it's effectively the same. And most importantly, what subnet ID are we actually going to be associating the lambda function with? And I'm obviously going to put it in one of my private subnets. And you'll notice there 172.31.98 network. So that's my private subnet that is actually, funnily enough, has my syslog ng connector in there. Click on Next. There's really not a whole real else you need to do a whole lot here. You can create a special role for the creation of the CloudFormation stack if you wish. As it says here, if you don't choose a role, CloudFormation uses permissions based on your user credentials, and you will know from the documentation that the actual credentials that are required, or the permissions that are required, are these. They're listed in the configuration guide. So unless you actually configure an IAM role specifically with the correct permissions, it will assume the user that's creating this stack or this formation to have those at a minimum for credentials. I'm using my own root account, so obviously I'm an administrator. I have those credentials, so I don't need to worry about that at this stage. And for everything else, we just leave default. There's nothing really we need to worry about at this stage. This will get our formation up and running. So we'll click on Next. Everything's ready to go. It gives us a summary page. And what you've got to do here is you've got to acknowledge that CloudFormation will create actual resources. So we're basically consenting to things occurring on our behalf. So just acknowledge that and then click on Create Stack. And just like you may remember from our CloudWatch installation in the previous video, this stack creation now starts to take place, and you'll see the status create in progress. And that will take a minute or two, and once it's finished, it will be up and running. Now, while that's actually being created, just like CloudWatch, we need to make sure that there's certain network level access for Lambda to actually send events to the actual syslog connector. You remember from the CloudWatch video, I deliberately didn't open up the port 1999 deliberately, so you would actually see those failure messages within the event processor. But I've actually already got those open now. But let's go and take a quick look at those so we can get a feel for it. So my default policy here that I apply to anything that's a syslog connector, syslog ng port 1999 from anywhere TCP. Now I can lock that down a little bit further and just make it so it's only from my private subnets. That would be an even better way to go as a security purist, but for the purpose of just getting things up and running, that's just fine. So while that's creating that stack, again, it takes a couple of minutes, still going. So all this information here, such as the description, comes from that installer.json file. That's effectively our CloudFormation template. So that's where this all information around what resources need to be created and so forth is actually coming from. And then Lambda itself will actually read external.properties from the S3 bucket as well for its own configuration. And so this Security Hub connector is my agent, my syslog ng agent, and it will be receiving the events from Lambda in Security Hub. So let's give that a couple of minutes. When it's finished, we'll come back and we'll start looking at some of the events. Right, so we're back now after a few minutes, and Security Hub is starting to send through some logs very, very slowly. It's important to keep in mind that it can take some time for something to actually show up, so don't think that you're going to be flooded with events straight away. So keep that in mind when you're taking a look at it. So we can see our events here, as we saw earlier in the video here. Some DGA type events that have come from guard duty via Security Hub. So when the actual stack has been finished in terms of its creation, you'll see if all has gone well, a green tick, create complete, and the template information itself. So you can go into the stack itself and take a look at the resources. If you want to look at any logs that have been generated in terms of the event processor and so forth, you can do that here. Click on the log group, because it is essentially sending logs of itself and its own execution back to a log group or a stream within CloudWatch itself. So just to finish off, in summary, the differences between the three different types of AWS connectors that we have. CloudTrail, obviously pulling trail information, VPC logs, very much on an operational level. What's interesting about CloudTrail is that it is actually picking up what you see there as Security Hub events. Now, it's important to keep in mind we don't mistake those for actual findings. So these are essentially programmatic calls to Security Hub to get things like insight results, security findings, and so forth. So they are the actual API calls and the console calls to those particular services. So these are not Security Event Hub findings. So we've got to be very, very clear on that. So these are CloudTrail logs, operational type of logs. Our second one is, of course, the CloudWatch connector, which is really giving us a lot of interface and VPC level network type information. So if I take a look at this one here, I know with a priority of 5, it's more than likely a network reject. So I can take a look at that, and information failure category outcome. So a network block of some description has probably occurred there. There we go. Device action equals reject, as opposed to these other ones where probably a lot of them are accept. So a lot of that subnet and VPC level accept and reject type events is what we'll see from CloudWatch. And last but not least, Security Hub. So these are the findings from guard duty, and remember, guard duty is the first iteration of the Security Hub capability that we're going to support, and we'll continue to roll out support for new products and services within Security Hub. So I hope you found that informative, and thank you for watching.